pretty acceptable. So welcome everyone, y'all, gang, robbers, thieves, pirates, whatever you want to call yourselves these days. I'm trying to stay gender neutral. But otherwise, thanks for joining me. Thanks for coming out and seeing this little chatteroony, this talk, this walkabout, whatever we want to call it these days. This is the kind of introduction to my talk tomorrow as well, what it's called Not So Secure Software Factories. Well, that's where I'll be actually digging into something and taking it apart and all this other fun stuff. But today, this is an introductory course. This is going to assume you have no knowledge of software development, containers, DevOps. Like if somebody asked you to make an app right now, you'd have a quandary, right? So, preliminary information to kind of set the tone.
What is DevSecOps? What is that?
DevSecOps.
Security.
Yes, it is the thought of including security in the forefront of DevOps. We've been doing DevOps for decades now. People want to get clerical about it. But now we've found out that these CI/CD platforms and pipelines and automation engines and all these other functions that we've built into each other don't have security at all. And not even the best of minds, or worse, really. So we're finding a lot of exploits and software supply chain issues that we wouldn't have really thought of, a couple of years ago. And this is something that actually other industries have had to deal with for decades, right? In distribution, in large machining practices, the supply chain is absolutely crucial, right? You don't want to get an Intel chip that's not actually an Intel chip. And they do make off-brand, fake third-party chips. So if you're putting that in your laptop and you're trying to sell it, that's an important thing to have. Now we're having that issue with supply chains and software and how it's being delivered as well. Not just how it's being built, but how it's being deployed and how it's being used. And that's a little bit more in-depth tomorrow. We'll go into the onion-like layers of container security and a couple other bits. But again, this is precursory sort of bits here. Now, someone said that software is eating the world. I'm really surprised that's working on my hotspot. I don't trust this Wi-Fi. I don't trust anyone here. I know better than that. Don't use any Wi-Fi at any convention. Don't use that anyway. But software is eating the world, right? Everybody interacts with software mostly right now through apps. Usually through their primary device, their phone nowadays. That's a weird thing to think, but that's usually most people's primary devices. So we see a lot of these apps. We see a lot of apps for apps. I just got this watch. I had to download 3 apps to use this watch. Absolutely insane, right? I did a smart home IoT jazz a few years ago. Did a smart things stuff before they were acquired by Samsung, which is cool because smart things had 2 apps. And Samsung bought them. So they made their own versions of those apps, of course. So then I had 4 apps on my phone, just for that little ecosystem. Not to mention the other dozen apps I had to run my smart home little enterprise, right? Needless to say, I've kind of gotten out of that, but IoT devices have not stopped becoming more prevalent, right? You heard about the oven that's smart connected now. LG's got one, and it can send you a text when it thinks that it's been on for too long, right? Like if you forgot it on, you're away from the house. But it's not smart enough to turn itself off. Huh. Okay, cool. This is smart stuff, right? Now we've got smart infrastructure as well. Okay. So anybody know what this is?
Oak Ridge?
No, Oak Ridge is a little bit longer in Colorado. That's a cool spot. Weird people. But this is actually Natanz. I probably butchered that name.
In Iran?
In Iran. This is a nuclear station, and it was hit with something that you probably have heard of called Stuxnet. Right? Now, arguably, that wasn't connected to the internet like a lot of these other smart IoT devices, but a software attack crippled this nuclear station. Okay. Infrastructure, right? And this is not even going into the recent attacks on Ukraine's infrastructure, and even locally, we've seen issues with power distribution stations. So now the smarts have started to become sentient as well. We've got connected little smart glasses with 5G devices that can scan people's faces very quickly, identify them. All right? You probably are thinking, it's like, that's, oof, we're not there, that's not us, that's them, it's not a problem. Okay? Keep telling yourself that. You might have heard about some of the stockade jumping issues that they've had at the New York MTA. Well, now they're installing some cameras with facial recognition capabilities. It is here. We've had this sort of technology kind of put in our faces for years, and now it's starting to become more commonplace with advanced software. And we're just kind of accustomed to it, really. Are we going to start chopping these off with hacksaws, too? That'd be kind of cool. Anyway, hopefully it's also going to our defense, all right? This is Nicholas Shalane's effort, DevSecOps across the entire DoD, which is pretty impressive. Now a lot of people have had some issue with GitLab before, about how they're selling ICE, and I think ICE is horrible and all this other fun jazz, and there is some moral issue there. But, surprise, surprise, every vendor you've ever heard of is selling to the government. There are hundreds of vendors in this software factory. You can check it out. It's actually some pretty cool jazz. But what's important about this is that it took the DoD over 10 years, over a decade to get on virtualization. And they've stood up Kubernetes clusters in months. That's the kind of heat that we're feeling from other actors. Okay? That's on a state level. So software really is starting to eat the world. And my name's Ken Moini. I'm here to scare you and tell you everything's still all right. All right? As everyone who even involves around security knows that our world is kind of broken, but hey, it's all right. You can see my ship programs on GitHub. You can see my ship posts on Twitter. Otherwise, during the day-to-day, I work for Fierce Software. We are a value-added reseller. A lot of other VARs just move paper around, but we do a lot of extra fun stuff. Hands-on workshops, webinars, consulting, a lot of hands-on engagement. Our enablement forces is what kind of sets us apart. And we specialize with public sector entities, so we actually work with Nicholas Shalane, who put together that DevSecOps initiative with the DoD. We specialize in secure platforms, DevOps, and data analytics, which usually go hand in hand pretty well. My job as a lead solution architect is to put a lot of these things together and mash them until they work for our customers. And that's usually really fun and also nerve-wracking at the same time. But we have got amazing capabilities in just a couple of these platforms that we use. And thinking back to whenever I did QBasic, like we've come a long way, right? Like I'm not setting IRQ settings for my new Sound Blaster card anymore. Okay, so how did this happen? How do we go from such simplicity to such a large, complex, technologically evolved world? How is software eating the world, in fact? Well, some people would say it's, these boot camps. Everybody's got these software boot camps. Learn Django in 31 days. And that's fine for its purpose. If I want to learn Django in 31 days, cool. If you're a PHP programmer, you want to learn Django in 31, you can probably go through those and do pretty all right. But they're missing a lot of fundamentals. So what happens is that I spit out people who know Django. Nothing underlying. Nothing as far as how to work with open source, how to contribute with a team, how to work in enterprise. I've got friends who have done this exact same thing and they've been stuck because they can't really fit into a cohesive software practice. But they are very helpful. They've exposed a lot of people and they've actually gotten people a lot of different good places. Another argument is that the internet is a lot more available now, right? There's a lot more information out there on it too. You don't have to listen to dial-up tones and wait for things to load. If you want to search something, I can okay, Google, hey, blah, 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 and it gives it to me on this. It's so fast. That's the internet. That's a good argument too. I would think that, computers now are just kind of a little cool, hopefully. I keep telling myself that. I've been telling myself that since I was a kid, but I hope a lot more people agree with me. One of the other things that I think really helps is that there's usually a decent bit of money in it. Money's also cool, right? Lots of people like money. Developing, you can make a lot of money, and that is, again, cool, and you can do it all from the internet. Most important, though, is that it's easy. Oh my gosh, it's so much easier now. All right, like you want to build an app, you can build an app in a short amount of time. You can take an idea, go from concept to actual production, money-making business without writing a single line of code now. You can do it all from the internet. And you can learn how to do it all on the internet. And it's so easy. All you got to do is pay $10 a month to some subscription service like Skillshare or whatever they're hawking online now. And Linux Academy and the Udemys and all this other stuff, cheap, easy, boom, easy. It's all about ease now. All right? I think that's really how things have kind of exploded. One of the other things that have kind of helped is we've kind of gotten our ducks in a row over the last couple of decades in the technology industry, right? Not to say that there isn't lots of innovation out there, millions of open source projects, but through decades of learned practice, we've standardized, we've optimized, and we've automated. This theme is going to be very important. I operate in threes, and you're going to see a lot of car and factory references. All right. So one of them is this amazing new tool. All right, that you can standardize on. Anybody done any sort of car work? Out of curiosity, change a tire, even brakes, whatever. So simple stuff, right? Cool. You can YouTube it and learn, right? That's literally like there's some weird thing that goes on with someone's brakes. So I'll YouTube it, find out, oh, that's a pin I just got to replace. Cool, got to go buy that $5 part. So if you do this enough, you learn that if you work on imports or domestic cars, you end up with two different tool sets, right? Soon enough, hopefully, maybe you can standardize on stuff. But otherwise, there's a different form of standardization, right? Like, I have a bunch of tools at home, and they're all lime green. Ryobi's, the OnePlus platform, I've standardized on their tool set, and I just plug in a battery in this, and plug in the battery in this, and then I got tools here and there and everywhere, and it's great, right? I can do anything I want, basically. I've got saws I've never even used, but I can use them. Now, if you are like me and want all these lime green little components everywhere, then don't worry, you get into this little eye chart that did not scale that well. But there are hundreds of different open source software libraries out there that you can choose from as far as tools. But whenever you are thinking of tools, the only thing I will say, whatever your objective, whatever your workflow, whatever your mission is, check out open source, all right? This should already be kind of instilled into most of us, but open source kind of keeps you away from lock-in. Ask anyone who's had to deal with SAP, a lot of Oracle. Amazon had a party when they switched off their last Oracle server. That's how momentous it was. That is really cool stuff. But whenever you do go to open source models, you do have that little brevity of being able to migrate or do other things or integrate in things that are just much more capable than closed source proprietary. This is the software you get, this is the only thing you ever get sort of model, right? So we standardized our tools, we're standardized on open source. Now we are optimizing our processes. Optimizing is pretty key because you can take a very clunky process that takes days and weeks to minutes with proper optimization. Ask any C developer and they'll tell you that much, right? Java as well. Oof, don't talk to me about memory management. But optimization is very important because without that you can't properly automate. And we've been automating for decades too, and we're getting a lot better than just bash scripts, which is really nice. So this is the trifecta again. Without standardizing on a set of tools, we can't optimize our workflows to automate, if that makes sense. If you've got 18 different sort of platforms to support, 18 different ways of doing something, your workflows are not going to be optimized. Your processes are not going to be automated. And even if you do try to automate all your different processes, you're going to spend more time maintaining those automation workflows than it gives you any in value, right? So now we're kind of getting into this automation bit, and I am here to kind of quelch the common thought that robots are going to take our jobs. Automation is going to destroy the industry. Computers are just going to be bleeping and blooping, and humans are gone. 10 years, 12 years, whatever AOC said, we're all gone. It's just going to be computers. But don't worry, robots are actually our friends, right? So automation is here to help you, not to replace you. Automation will be the thing that sets us apart as far as the actual ability to adapt. Human beings supposedly have the inherent ability to adapt, right? And automation is coming, and being able to use automation is absolutely crucial. Think about the power tools again, right? I got a screwdriver, I'm told to build a deck. I don't want to build that deck. You give me a impact driver and a good drill, I'll build a deck for you. But you have to learn how to use that tool right, because if you don't, you're going to poke your eye out. So that's the difference. Learn how to use the power tool, right? So learn how to use these robots, learn how to build these robots. And again, we've been doing it for decades. We've been building bash scripts and Python scripts and Perl scripts for days and days and days on end. But that's been usually secluded to a small subset of people, right? You have to know how to program in those languages to actually use those automation processes. So we have not really enjoyed automation as a society. It's because it's still kind of hard in most cases. If you are looking into IoT, smart home, automation sort of stuff, honestly, I wouldn't really even bother for a little while, because even if you do try to automate all your things and tell your Alexas to, set your scenes to this, that, and the other, it doesn't really work out that well all the times. A lot of events miss. It's really hokey. Yeah, you spent a lot of time setting it up. One thing breaks, you have to start all over again. It's just hokey, all right? It's not simple. Now, what is simple though, I think, as far as automation, and this is one of the key takeaways, if you're not automating, if you don't know an automation platform, I suggest Ansible, because pretty much everybody can use it, all right? So there's Chef and Puppet and this, that, and the other out there, and a couple other platforms, and hey, you could just you can automate with PHP if you really want to. I've seen PHP shell scripts. OSEC. But learn automation. I think Ansible is great because it's extremely simple. With the others, you have to learn Ruby or Python or some other sort of subset to actually really use it. Now, cool thing about Ansible is that you can read it from top to bottom. It just executes. You can read what's going on, and pretty much anybody will understand you. I can give you a playbook right now, and you'll be able to read it. I can give my CEO a playbook, and he'll generally understand what's going on, right? As long as I document it, comment what tasks are going on. You can use it for pretty much everything, not just application deployment, not just web servers or whatever. You can ping network endpoints. You might have heard of Starbucks. Throughout their entire enterprise, they use Ansible to automate their network. Tens of thousands of nodes, all just with a little push button. That's pretty cool. You can do it with a lot of weird stuff. I gave a talk a couple years ago somewhere else about automating my home network, which has dual WAN capabilities, all this other fun stuff, with a Lambda fired function for an Alexa skill, so I could yell at my Echo and restart my network. And just whenever I felt like terrorizing my girlfriend. One of the other cool things about Ansible is that it's agentless. That's really important. In secure enclaves like the ones that I get to work around, a non-negotiable thing is putting an agent on a box. I mean, I'm going to have a piece of software running on all your machines with root access. Okay. Like, that's not going to happen the DoD that easily. Sometimes for some things, but you have to get special clearances and indemnities. But it's agentless, which means that it can interact with APIs. It can interact with Windows machines. It can interact with Unix machines and all sorts, right? Very important. A little bit more secure that way too. So what does it look like, right? This is Ansible playbook. Let's read this together. Install and start Apache. On what hosts? All of them. We're installing servers everywhere. Variables. Anyone who's programmed, done automation, you know that you need variables in to modify your execution, right? Okay, so simple variables. HTTP port, max clients. No problem. Remote user, root. I'm going to talk about that. Tasks. We're going to install the HTTP package. The Yum module, we're targeting the package HTTPD, and we're ensuring that the latest version is out there. Cool. We're going to write some configuration file with a little templating module. We have a template file. It's going to take some of these variables and put it in there, and then we're going to start the service. It's pretty human readable. That's pretty easy to understand. And we can push this out to thousands and thousands of machines like that. And we can run it again. If we run it again next week, it's going to make sure that Apache is updated because it's going to make sure that the state is latest. Very cool. And this is YAML. I'm actually told that it's not yet another markup language. It's something else. It's like a recursive acronym. But either way, this should be pretty simple and pretty easy overall. Which again, we're pushing that easy button. Okay? Now, if this looks familiar to you, then you're probably in the DevOps ecosystem because pretty much everything is YAML with that sort of jazz, right? If you're doing any Kubernetes fun stuff, it's all YAML. I'm about to change my title to YAML engineer. But otherwise, that's kind of where it goes into our next little bit with the DevOpsy bit. We're automating, now we're going to kind of keep optimizing, right? And this recursive cycle is kind of what's kind of feed our system. But before we get to DevOps, again, this is cursory sort of information. What is DevOps? Who does DevOps? I hate that phrase, but who does DevOps in their enterprise, their team, organization, at home? Last year I told y'all to get home labs. Y'all got home labs? Yeah? You're doing DevOps in your home labs now, right? Oh, okay. That's okay. I burned mine out too. It's okay. But it's good. We've got a couple people who are doing it. When you think about DevOps, if you sat through any sort of, presentation online, a little webinar or something, you probably instantly think cloud. Ugh. There's a cloud, and containers, pipelines, pipelines, and synergy, vertical integration, customer experience. All right, that's DevOps, right? Yeah, kind of. That's where this eye chart of, why did it scale properly on that? Oh, whatever. This is where this eye chart of tools comes back to haunt us again, right? This is what people think when they think DevOps sometimes. Which, there is a lot of DevOpsy stuff here, but you don't need to focus on this, okay? If we boil the ocean and we render the salt, what do we get? Everything's YAML, like I said earlier. Everything is code. If you don't work with Git, you need to learn how to use Git. If you don't have a GitHub account, all I've got to say is it's 2019, y'all. It's 2019 if you don't have a GitHub account. My boss has a GitHub account, and he's a sales dude. He just stars all of my repos. I don't know why. But either way, DevOps, a couple other core tenets, is at this point we've been automating, right? I should have drilled that into your head with one of those bright green Ryobi joints. We're automating everything. And with that, we're trying to automate the process of automation, so this pushing to Git, that actually kicks off another process. That continuous integration will help deliver an application maybe later. And then that means that as we commit, our application should be releasable if it's in a pipeline that's continuously delivered, right? Well, we're pushing out applications thousands of times a day. Cool. The push of a button. That must be marvelous. Good golly on your Jenkins server. But without monitoring, without seeing the logs where you're failing, without this rapid feedback, you're not going to be able to figure out what's going wrong. And whenever you move to this DevOps container sort of life cycle bit, you need these logs and this feedback to actually figure out what's going on, because you're not going to SSH into these containers. Okay, you're not going to go in and fix boxes. Something's wrong in the execution, you fix it and you rebuild, and then you redeploy. That's it. That's all you got to do. You're not fixing hundreds of boxes. You're pushing out hundreds of new images with your delivery pipeline. So cool stuff. That is DevOps, and we've got this, synergy thing. That's all the fun stuff. And unfortunately, for most organizations, they can only do a couple of these steps properly. Some of them can code properly. Some of them can operate properly. Most of them cannot secure and test properly. Gone in some large organizations where they don't write tests. And they're handling some part of your large amount of expendable income per month. But either way, that is DevOps. And before we think it's just two people fighting, it's the developers and operators, there's actually a couple other folks in the room that are trying to yell at you too. Okay, business is gonna business. They have tasks, they've got objectives. You got to make that sprint. Security is trying to make sure that you aren't getting bleedingly hacked, but somehow you still roll out default long-ago credentials. Your developers, well, they're doing whatever they're doing. A lot of these Go programmers, I don't understand what's going on. It's magic. And otherwise, your operators are just trying to keep the lights on, make sure that nothing breaks, explodes. So we've got a couple different actors. And there's a little bit of war, a little infighting, usually, right? Problem, again, if you develop or boil it down, the relationships are dumpster fire. We need to get better at working together, y'all. What we've been relying on is just throwing things over the wall, as the saying goes. So as a developer, I'm just going to throw my code over the wall and hope it works, right? Operations is like, I've got an application, here you go. And security's like, no, that's still boiling out of the pot. What are you doing? Go back. Okay. This throwing over the wall practice doesn't really work out that well, right? We've had these troubles. And we've had more troubles. And usually, again, if we boil things down, it's with software, it's with applications. Okay, so application delivery, application development, application security is extremely hard. All right? Even if you're going by best practices and this, that, and the other, for a layman like me, for instance, one time I had to set up a Hadoop cluster. Ran a little analytic pipeline. Great. Ingested some SQL data, this, that, and the other. Oops, I gotta go catch a flight. I'm headed to the airport. I installed the cluster with vendor instructions to the end. So I was like, I guess it's good, ready to roll. I'm saying in a little TSA, and I start getting email messages from Amazon. Hey, we're noticing some unusual activity from a few of your nodes. And I think, okay, that's weird. I just kind of dismissed it for a second. I was like, it's probably when I was doing the data stuff. I get another message. Hey, you really need to cut that out. Okay. A minute later, I get another message about Amazon threatening to disconnect my account. Lo and behold, that Hadoop cluster I deployed was hacked within a few minutes of me having deployed it. Pretty impressive stuff right there, right? Now, others you might have heard, default Mongo credentials, Hadoop systems insecurely set up, this, that, and the other. That actually has a lot of issues in our day-to-day life now, because we are so connected. So it's not just, oh, my database was insecure. It can actually affect other people's lives. So we've standardized, we optimized, we've automated this far, we've got that going. By doing so, we're a little bit more secure, because we're not doing all these other different things. Since we're optimizing our process, we're embedding DevOps. That should be a cultural thing. Again, it's not just technology. And now that we're automating, we're getting better at what we're doing. We're not messing up. A lot of practices that go awry are usually due to human error. try to eliminate the human error, and you're usually sitting better. If I'm not forgetting to turn off telnet, if I have it enabled for some reason, because it's a base construct of all of my pipelines, then great. I'm scanning that, great. So, we talked about containers real quick. You think that's going to solve our problems, right? This application delivery, with this software development problem, this DevOps thing, Now, it's kumbaya. Docker brought the champagne. Developers and operators are toasting. We're living the good life. Not so much. Who has messed with containers? Good amount of hands. Nice. About half. Containers?
Message being typed in a few commands and then, oh.
Yeah, I mean, containers are easy, and that's actually one of the key points. You just type in a couple of commands, and you're like, oh, well, that's cool. But it's that cool is very important. That's very powerful. That whenever you go, oh, that's cool. Think about what happens when a whole room goes, oh, that's cool, or a whole organization goes, oh, that's cool, or when a whole country goes, oh, that's cool. So if you're not too familiar with containers, the core bit of containers is process isolation, all right? So let's think about back in the day when we were running shared services on a single host, all right? We had these 1U pizza boxes, and you had an old HostGator, DreamHost, whatever account back in the late 90s, and it's all on one shared host, right? That was super fun, because back then when getting slash-dotted was a thing, one site could take down hundreds. Okay, so then virtual machines came and became commonplace. And then you got VPSs instead, quick little slivers of machines. And that way, you know, as long as the hosts aren't oversubscribed and all this other jazz, I know that my environment's kind of succinct and kept the same. So that is going to keep my hardware, my resources to its own. The important part there is, though, you've got a whole new machine. You deploy this VPS, this VM, you choose your operating system, a whole new operating system. Boom. You've got a whole new kernel address space and everything. With containers, again, it's process isolation. The container host actually extends its kernel into the container with an overlay file system in its own namespace and all this other fun stuff that I'll get into tomorrow. But with this, you have process isolation. So you still have a little, you know, walled garden around your application, but you're actually able to have applications deployed in a much more dense environment. So now you're probably thinking, it's like, wow, well, you said it's more dense, it's cool, you get some benefits from it, VMs are gone. No, not so much. VMs still have their place. They're actually great to move around, well, not that great to move around, but you can, you know, in a succinct manner. In a whole configuration. You can do that also with a container, because it takes a snapshot of that diffed file system. But it's a little bit more burstable. It's a little bit more elastic. You get that elasticity from containers. You don't get that with virtual machines. If I have to scale up a virtual machine, I'm going to have to turn it off, change the type, and then scale it back up in most hypervisor environments. All right? So you're probably thinking, like, wow, this container stuff, it's cool, it's new, you know, not too many people are doing it. It must be some hot jazz that they just introduced. Actually, it's not. Again, process isolation, file system isolation, namespace isolation. A lot of these functions have been in the Linux kernel for decades. It's just been very difficult to make manual system calls, ad hoc, en masse, to orchestrate the deployment of an isolated function. Okay? And then a few years ago, you know, the whole Docker thing happened. That you probably heard of. Docker made it kind of explode a little bit, right? So, and those short few years up until recently, we've had, again, an explosion of activity in this ecosystem. Why is that? Well, it's easy. Like you said, you can run a command, Docker build, tag it with your tag, and you run. You run your container. It's easy. And that's it. You can do that, right? You're doing containers now. Might even be able to call yourself doing DevOps. So, that's all cute and quaint and fun. What happens when you have more than one container? Okay. Well, we can put a bash script together. I've been doing that for years. Just inception automation. We're going to build a couple different containers, no problem. And then we're going to run it, and then we have to link it to each other, right? Because containers, again, it's process isolation. So for some things, they're denied by default. For others, you can get through, well, that's why a lot of people are doing containers wrong and insecurely. But otherwise, you specifically have to build out these sort of relationships. So containers and DevOps en masse is actually very, very difficult. And I haven't seen anyone that's mastered it, really. But it's still offering a lot of powerful capabilities. All right. So our next victim of dissection is Kubernetes. It is that hot jazz as of a few years ago. Before I give my explanation, anybody care to give their opinion of what Kubernetes is?
So hot.
Who got through? It is evidently hot stuff. So Kubernetes is a project by Google that they open source. It was dog fooded for about a decade beforehand. But Kubernetes is, and I'll read this off the screen, I think it's pretty succinct, an open source system for automating deployment, operations, and the scaling of containerized applications across multiple hosts. Sounds like it's gonna be the stuff of our DevOps dreams. Solve our container conundrums, right? And that's pretty close to what it does. You throw containers at Kubernetes and it's going to schedule these containers across your infrastructure. You tell it how you want it to communicate and it does that, right? But anybody here deployed Kubernetes themselves? Couple. All right. So there are a couple ways of deploying Kubernetes. There are a bunch of different ways of deploying Kubernetes, actually. One of them you might have heard of is Kubernetes the Hard Way by Kelsey Hightower. He goes deep level, setting up the SSL certificate authority, showing you how to manage your public key infrastructure in order to just get started, right? So there is a very difficult way of doing Kubernetes, and whenever you do start to build Kubernetes, even if you go with the quote easy way, you find out that Kubernetes is not actually just your end-all be-all. You can't just stick it in your CI/CD pipeline and just call it a day. That would be great, though. Whenever you build out your Kubernetes cluster, you find out that you need some networking. It does not come with networking. So you've just got containers and pods just chilling, running in place, burning energy. Good. So you gotta stick some networking in. Some deployers just throw in like Flannel or Weave, OVS, but otherwise you gotta bring that in yourself. All right, now where are you gonna get your containers from? Everyone's first answer is Docker Hub, yay. We're just gonna pull in some random container, right? I trust it, but what would be better is to not have every one of my nodes calling out to Docker Hub every time that they call a new container image to run and pull down. So we should probably have our own container image registry. All right, that's gonna be very helpful. Like if you wanna call yourself doing Kubernetes and you ain't got a registry, you're doing something wrong. All right, now again, interacting with the Kubernetes cluster, you can do it through the command line, but otherwise it's all API based. Like if you can make a REST call to an API endpoint, you can interact with Kubernetes and build platforms upon it and do some really, really cool things. But it does not really extend logging. You can get some logs, but they're not persistent. Not easy to access. Again, it's not easy. So you're going to need something to precipitate that upwards to your users, to your developers, to your operators. We need some way to manage our life cycles. Because what happens whenever we have a new container image come in? If you have a new container image in your registry, it doesn't just automatically go, okay, cool, I'm going to do a rolling deployment for that. and you kind of push that and actually make some calls. So now we're building services, right? So now that we're building our own services to run Kubernetes, I guess, well, we need databasing. Like we're going to need some Mongo and some document storage to, manage the data that we're trying to manage on this platform that we're trying to run to build There's a lot of inception here, right? Actually, you find that a lot with Kubernetes. All right, well, since we're doing all this and since we're building a platform on this platform, we might as well make a web panel for it too, make it nice and easy, since we're trying not to stay in the command line all day long. Okay, so you thought we were done. You thought that was Kubernetes. Well, you're still wrong. There's still a lot of things that you need to build into it to actually make it usable, right? And that's where you kind of get hit with this little eye chart again. This is all the fun Kubernetes stuff that you can go into. There's some networking options, registry options, some configuration as code options, storage options. That's real fun. What happens when Amazon decides to, call out new EBS store in a region that you don't have nodes connected to, so your pod's just calling up block stores that it can't connect to? That happens. That's real fun, unless you figure out how to fix that, which a lot of people don't. But either way, I know you're thinking, you thought I told you this is all easy now, right? But it seems really complicated, and it is. That's definitely true. It's very complicated. Anybody who does Kubernetes tells you it's very complicated. The deeper you get into it, the more complex and the more you don't understand. So let's put things into perspective if you think the ease of use is still not there, all right? Think about your car. Your car, objectively, is pretty easy to use, right? I need a motor vehicle. What's the thought that comes into your mind? All right, your next objectives are procurement. I need some money. All right, you go get the money, you buy the car, you got the car. Good. You need to put some gas in the car, you can get it going. And then what do? You get in the seat, you turn it on, as long as everything works. You push a couple pedals, turn this little thingy, and you go. That sounds pretty easy, right? That is arguably very easy. Now, software is making it even easier to where you don't have to do most of that. And it's actually running people over. But otherwise, we're not there to Jetsons yet. Otherwise, whenever people think of, I need a vehicle, they don't think about all this. This is complex. This is the factory. These are the robots. This is the automation. This is the standardization and optimization of workflows that gets you that easy, push, start, and go. A lot of people don't realize that, right? They don't sit behind and see the things that go on in the background. So whenever you're using some of these new software platforms like Webflow, which is pretty cool, as a tenured programmer, I checked it out. I was like, yeah, this is nice to make web pages. But there's no code. You don't code at all. But everyone's website runs in a new pod, in a new namespace on a Kubernetes cluster. You pay enough, they give you your own cluster. But I can go click, click, click and have a new website. It's running on Kubernetes and a pipeline and all this other fun stuff. It's easy for me. I can get up and go and drive. That's the easiness, right? This is complex. This is hard. So, thinking about that factory, let's think about what factories give you. All right, Model T. Great example, I think, for software. Because again, I mentioned earlier, there are other industries who've had these problems that have kind of solved them, and software is just starting to play catch up. So the assembly line at Ford Motor Company, was absolutely revolutionary, right? Nobody can argue that. It took the process of building a car by hand. Like, you guys want to build a car by hand, okay? And those are a lot more simple than our cars nowadays. It took them 18 hours to build a car. So a day and a half, at least. 3, but whatever. It took you a little while to build a car. It took that assembly line, that factory, took the process of 18 hours to make a car down to 3.5. So within a decade, they went from a ho-hum motor company to building over half of the cars in North America and about 40% of them in Europe. That's quick capability, right? And that's what we're kind of starting to see today. And we're starting to see that today with software factories, okay? Because they're easy to use. Once you got them set up, once they're ready to rock and roll, once you've operationalized them, once you've optimized your workflows and made everything automated, where it is as easy as click, click, boom, they have pretty impressive capabilities. USCIS has a standardized software factory, and they laud their accomplishment of being able to take a new developer and in the same day having them deploy a production system in their pipeline. 80% of their applications get deployed within their application pipeline. It's pretty impressive stuff to be able to upskill someone that quickly and to be able to get them pretty advanced weaponry that quickly as well. So we're building applications all day, every day. Everyone is doing it, right? But not everyone's doing it right. Let me give you a couple thoughts. Where are you getting your software from? All right, I mentioned open source software earlier. Open source software is great, but what's behind the sheets? What's under the covers? Sometimes can be pretty scary. There was some report run the other day that said there was only like 12 node modules that if any of them were compromised, it would in effect compromise the bulk of applications running on Node out there. Just a couple foundational packages, right? So what packages are you pulling in? Now that you're building these sort of integrations with your GitHub repo, with a vault, because you got to store secrets somewhere, with your Kubernetes cluster, anyone can quickly access. You're building all these different connections. What if something is compromised? Docker Hub got compromised not too long ago and was found out that everyone's keys were taken as well. So if you had a GitHub repo attached to Docker Hub, you had that integration compromised. Something that not a lot of people think about. Now you're doing Kubernetes, like it'll get out of your hands very quickly. This is a very complex system. You need enablement, you need training, you need upskilling. Because I've been working with stuff for years and I still don't understand it fully. Like I've made custom resource definitions and some of the underlying subsystems are still complex. On top of that, think about this. We've standardized on Kubernetes. It's all written in Go. There was a Go SSL library vulnerability discovered not too long ago, and guess what? Everyone's Kubernetes clusters were vulnerable. Everyone's. So you got this really quick patch. But enablement is extremely important. So I'll be discussing some of those tomorrow in my not so secure software factories discussion, where I'll actually be taking a couple of these bits apart, showing you how to attack these software factories and how to defend against them. But for today's takeaways, again, software is eating the world. So don't let it eat you. Okay? Amazon pushes out their applications thousands of times a day. If you've ever loaded Amazon.com and 10 minutes gone back later and went, this looks really different. Not just the ads, but just like the actual layout, the page, the way you interact with it is different. They do psychological testing thousands of times a day, blue-green tests, to see if this version is going to make you click and buy more and faster and more often and get you into their ecosystem even deeper. That's your software factory at Amazon. You know, you need to learn automation, but whenever you do, make sure to do it securely. I love to pick on Tesla because they quickly deployed Kubernetes clusters everywhere. They thought hey, we're paying someone $750 an hour to do this Kubernetes thing. They must know it pretty well, except they left their dashboard open, publicly, unauthenticated, for anyone to access and control. Yeah. Outside of that, your CI/CD pipeline should be treated like gold. It should be a first-class citizen in your considerations. Webmins. Anybody use Webmin? It's like a cPanel, but free open source. It lets you control your Linux servers with a GUI. It's whatever. It's cPanel basically. Plesk. But Webmin's CI/CD pipeline had been compromised, and they found out that it had been compromised for about 3.5 years. So if you've used Webmin within, I'd say probably about the last 5, you're probably running vulnerable software on your server without really knowing it. All right?
Can you say that again? If you're doing what?
If you're running Webmin on your server, well, I mean unpatched as it is right now, you're running vulnerable server. They had their CI/CD server, Jenkins server, it was hacked. And since it is the automation server that builds all their software, they said, well, just stick this in here. And it's got Webmin's, PGP key securing the application. It's coming from Webmin. You download it. There's nothing weird or spooky about getting this application when you look at it. But you don't know that it was built with some malicious code.
I hadn't heard about that, but I never trusted Webmin.
It's hokey stuff. It's some weird stuff. I mean, it came from an era of web development that should have definitely been buried with the whole geocities thing. So now everyone is building software, and any company is a software company now, right? And I think if you've been in the tech industry for at least a couple decades, or even a few years, you might have noticed the uptick in vulnerability reports. This person got hacked. This software is insecure. This has got a backdoor. That's got default admin credentials. We're probably seeing that because there's just more software out there. There's more people active on there. There are more people using it. There are more people attacking it. There's just more of it. So, you should probably learn how to build some software and how to attack it, which is my fun part. Which we'll be doing that tomorrow. But for this, any questions, comments, concerns, qualms, queries, conundrums, projectile from a peanut gallery?
You're going to be attacking some software tomorrow?
Yep, and showing you why you should think about where your Java components come from and all sorts of fun stuff. And hopefully spinning up an actual software factory. I've got one of these little things automated. You just click, 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 and then it gives you all these little Kubernetes manifests and deploys it. It's pretty cool stuff. But, yeah. All right, excellent. Well, thank you all for your time. Thank you for being here. Again, check me out on the tweets and the geeks. Otherwise, we've got another fantastic chit chat coming up here shortly.
Thank you.